Hey everyone, welcome to the Data Strategy Podcast, where we discuss everything in the world of data architecture, data governance, and data management. I'm Dave Kruse, the CEO of Augment, a digital AI and data consulting firm in Madison, Wisconsin.
And I'm John Hwang, head of data engineering here at Augment.
All right, thanks, John. All right, so we spent all of our previous podcasts talking about data and all the things that can go wrong, and all the things a client can do to make things go right. But let's talk. But this time, let's talk about Augment for a second, and how do we apply these best practices, and really what makes us different from other firms.
Yeah, I mean that's the big question, right? So firms that handle data engineering engagements, all of them seem to think that they're great at it, right? But the question I would have for them is how do you know, right? Remember what we said about how data platforms don't actually fail right out of the gate.
Right. Okay. Right. So we said that they get released into production. Everyone celebrates, has a party, but then they start to show their age as clients take it over, and then they try to build more use cases on it.
Yeah, and that's a process that can take, a year and a half, maybe even 2 years to show itself. But these outside firms that clients hire to build their data platforms, they're gone by then, right? And if the client isn't happy with them, they're never calling them back. So these firms that say they're good at it, I'd say you're good at building them, granted, but how do you actually know what happens after that, right? Pretend I'm the client. Can you articulate to me what the difference is between a data platform that is still relevant and growing 2 years after it's built versus a data platform where the client is looking to replace it 18 months out?
Right. And it isn't really even where their focus is. I mean, they're worried about building something as quickly and cheaply as possible. And they're not as concerned about what the platform might look like 2 years from now.
Yeah, it's true. And unlike some of these firms, we can tell you from years of experience building long-term relationships with clients, from sticking around long enough to watch data platforms succeed or fail, and from being called in to fix broken data platforms, we can tell you some of the key things that cause these failures, right? What causes them, and I think more importantly, how you can avoid those things.
Okay. Well, yeah, John, let's go over those then.
So clients clients have some kind of business goal that they want to achieve using their data, right? That's not an end by itself. And so when most clients face data platform problems that roadblock those goals, you can categorize those problems into some combination of four buckets, right? Number one is it takes too long to build for new use cases. Two is it's hard to share data across organizations. Three, it's too expensive. And four, performance is slow, right?
Okay.
Usually the problems that clients talk about fit into some combination of those four buckets.
Okay. And is that order that you went through actually important?
Two through four, not really, but it certainly is for the first one, right? The one where it takes too long to build, right? So for many issues that fall into that category, there are just so many bad decisions that come from trying to work around that one, right? And that's the category that we are hyper focused
Mhm.
on, right? Um, Now, none of these categories exist in a vacuum, right? They're all kind of related to each other in many ways. So sometimes if you address one, it becomes at the very least easier to address the other, right? But that first one really is the keystone, right? If you can shorten build time, that gets you a lot. So let's say, for example, and we've seen this, right, where a client comes to us with a problem and they say that it fits into category number two, right? It's hard for us to share data. And you'll hear some clients refer to that as data silos, right? So our data can't speak to each other, right? And so we need to figure out how to solve that problem. And a lot of times it comes down to the fact that it takes so long for a central data team to incorporate data into their platform that each department is essentially within a client org is essentially forced to build their own kind of mini data warehouse. And that's how a lot of these silos wind up getting built. And so when a customer comes to us and says, "Hey, we're having this data silo issue," rather than taking that topic head on, we tend to try to pivot the conversation and ask them about time to adoption, right? Because a lot of times, if you address that issue, right? So now you can build rapidly with a small team with mixed levels of experience. Once you achieve that, it becomes much easier to address the data silo problem. And in fact, a lot of times that problem goes away just by itself.
Okay, that makes sense. That makes sense. That's helpful. So, how does all this give us a different approach to client issues, really, and how is any of this really useful knowledge to us?
Yeah. So what we've done is we've tied a set of standardized best practices that draw where we can draw a direct line from those best practices to back to those category four categories that we mentioned, right? And then we came up with a standardized architecture that aligns with those best practices. And then we created a standardized playbook to quickly implement that architecture.
Okay, and all this boils down to what we've been calling our data platform accelerator.
Yeah.
And this idea is really rather than box software to help clients with their data platform build, we have a boxed solution, right?
Right.
Okay.
Yeah, so our data platform accelerator, right? It has this standardized architecture, standardized playbook with a set of about 20 tasks and technical assets that we pre-built. A lot of cases, these are pre-built functions that further accelerate that build, right? So because we have this standardized architecture, we know exactly what needs to be done coming in. So we can start development not just day one, but hour one, right? The standardized architecture is the we focused it on being able to accommodate rapid builds that can be supported by a small and even an inexperienced staff, and it's made up of a simple tech stack, right? And the standardized playbook that we have to implement that architecture means that it's mostly a repeatable build process for us, right? And more importantly, it's a repeatable build process for clients once they take it over, right? So they can do the same thing that we do when we first meet with them, which is as new use cases come up, you ask, rather than asking, how can we build something for these new use cases, we instead ask, how can we fit those use cases into our standard model, right? And are there any adjustments that we need to make to that model to build for this particular use case? It really just boils down to smaller questions like that. So it becomes a much shorter conversation and it becomes a much shorter build duration because we know all of these things up front.
Okay. But I think a lot of clients would argue, and they have argued, that their problems are super unique. And really, how can we come in with a box solution that we know can help them?
We've seen this help clients. We've seen this accommodate well over 90% of use cases out there across pretty much every vertical, right? And the analogy that I like to use for this is Legos, right? You can use Legos to build whatever, a car, castle, spaceship. Um, each build, though, right, you're still using the same blocks fundamentally, right? Similarly, every engagement might be different when you look at it as a whole, but the reality is they're all made up mostly of the same building blocks, right? There are only a few kind of specialty blocks that you need for each build. So the standardized architecture allows us to break things down into smaller pieces. Most of those pieces are the same from one engagement to another. So those tasks involving those same blocks, those are standardized. Going into an engagement, we know a majority of the technical tasks that need to be done before we even have our first conversation with the client, right? That's our standardized playbook. And what that means is, yes, there are things that are going to be unique to the client, but that's not everything that's going to be unique to them. It means that we can focus our conversation, we can focus our attention and energy on these few tasks that are actually going to be different from engagement to engagement.
Okay. That all sounds good, but can you give a specific example of something that we do with our data platform accelerator that actually accelerates things? So, like, what's something that we do that a client might not have thought about before?
So one of the things about the accelerator part is that it doesn't just refer to accelerating your data, but accelerating your build process. And one of the things we found is that most of the time that it takes to build a data platform is actually in the testing, not the development, right? It's different than, say, when you're building an application where you can just kind of use automated testing to make sure that the application runs and that the various components of it are kind of properly interacting with each other. But for a data platform, you have to test the data, and that is
Mhm.
almost always manual, right? The code might pass a unit test, it'll run, but has it changed the data in a way that the users are expecting, right? If your code errors out, you know where to look. That's not really an issue. But if your code runs properly and your data is still wrong, then
Mhm.
it's really hard to figure out where it all went wrong. So one of the things that we advocate is break your pipeline up into discrete steps, right? Steps that can each be run on their own, and the output of each step is a persistent table with the data that results from that. That table is simply then the input for the next step in the job, right? And this way, what happens is that when there's an issue with the data, you can check each of these intermediate tables to track down where it all went wrong.
Okay. Now that is definitely something different than what a lot of people do with their pipelines, right?
Yeah, it is. Traditionally, ETL pipelines have been monoliths, meaning that even if internally it's going through steps, you couldn't see the data until it was all done. You didn't get to see the data and be able to analyze it after each step. And it tends to be more performant that way, right? And you rely more on memory than disk by doing it that way. You can do multiple tasks with a single scan of the data. And in a time years ago when an ETL pipeline ran for hours, squeezing out every last bit of performance was critical. But today, when a typical pipeline runs seconds to a few minutes, right? In that kind of environment, suddenly losing 10% of your performance isn't that big a deal if in exchange you gain this ability to easily
Mhm.
analyze data issues.
All right. Yeah, good point. And just to be clear, this isn't the only thing that we do.
Right, right. Yeah. I mean,
Okay.
this is just kind of one example, right? But it's an important example, I think, because it demonstrates the trade-offs you're always looking at whenever you're building a data platform, right? We kind of, as human beings psychologically, we just like to kind of focus on the positive impact of each of the choices that we make. And we have a tendency to kind of ignore the negative ones, but each choice has a pro and a con to it, right? So, yes, it's great to make the most performant and efficient data pipeline possible, right? That would mean kind of the things we just mentioned about relying as much as you can on memory, scanning your data as few times as possible. You want to kind of do this all in as few lines of code as possible. That's great, but there is a negative side to that, right? Because what you lose by doing that is there's this opaque curtain that forms between person and data, the difficulties in testing the data when it goes wrong, right? When most of your build time is testing, this efficient pipeline suddenly means that your build time gets bloated out into months, as opposed to doing it our way, where it's not as performant in terms of running the job, but it means that the build time now suddenly takes, rather than months, takes days.
Yeah, and that's a super important part. But is that an exaggeration, or is that actually how much time that really could be saved?
So we focus on data platforms where a single use case can typically be built within no more than a 2 week time box, right? Many organizations are looking into to use agile development models, and that's not possible when it takes months to build for a single use case.
Okay, and 2 weeks that's the upper limit.
Right, right. Yeah, that's the ceiling, right? We've seen simple use cases being built in hours.
Just hours.
Yeah, it's weird because in cases like that, like the meetings to discuss the use cases took longer than the
Right.
actual build.
All right. Well, we can keep going for. I know John can keep going for a long time, but let's. I'd like to stop there. But this is a topic that merits more discussion in the future. But until then, I guess please check out our other data podcasts and keep an eye out for more conversations on our data platform accelerator. And on behalf of Augment, we appreciate you listening, and we'll see you next time. Bye, everyone.